Welcome to all. Again, we are here for examples on the concept of unit speed reparameterization in case of differential geometry. Now we will consider example on unit speed reparameterization. The question is, show that the curve alpha of t equal to cos ht sin ht t has arc length function as s of t is equal to root 2 sin ht, and find unit speed reparameterization of alpha. So what they asked is, they asked that the arc length function of alpha of t is, we have to show the arc length function of alpha of t is s of t is equal to root 2 sin ht, and using this arc length function we have to find the unit speed reparameterization of alpha of t. So the unit speed reparameterization by using the arc length function is like the procedure for showing that if alpha is a regular curve, then the reparameterization of alpha will be having unit speed. Just we have to follow the steps of finding the reparameterization for regular curve, and we will arrive at the result. First we will consider, we have curve alpha of t is equal to cos ht sin ht and t. So we can observe there is nothing like the arc length function is based at something. So if nothing is given about the base of the arc length, we are taking, assuming that, or taking arc length function s of t is based at t is equal to 0. Therefore the arc length function is given by s of t is equal to 0 to t norm of alpha dash of u into du. So to differentiate between these two variables t and, so here we can write alpha dash of t. So differentiate between the limit variable and the variable of the integrand, we have taken alpha dash of u and du. Now it involves the magnitude of the velocity vector. First we have to find the velocity of curve. This is alpha dash of t is equal to cos ht is sin ht sin ht differentiation is cos ht and t is having 1. So we can observe for any values of t, alpha dash will be never 0 because the third coordinate is a constant. Therefore alpha dash of t is not equal to 0 for all t, which implies alpha is a regular curve. So if it is regular curve, therefore we will follow the procedure for regular curve to find the parameterization. Now alpha dash we have got, norm of alpha dash will be under root the square of each component of alpha dash of t, sin h of t whole square plus cos h of t whole square plus 1. Since we know that 1 plus sin h square t is equal to cos h square t, so we can use 1 plus sin h square is equal to cos square. So this will give 1 plus sin square is cos square, and this is also cos square. This is 2 cos h square t. So as cos h square is, we can take it out, cos h square outside. This is root 2 cos h t. This is norm of the velocity vector, that is the speed function v of t. Now using this, the arc length function is s of t is equal to, as we have taken this from 0 to t, 0 to t into norm of alpha dash of u is root 2 cos h u into du. Taking out root 2 as outside because it is constant, 0 to t cos h u into du. So integration of cos h u is sin h u, and apply the limits 0 to t. This is nothing but sin h t minus sin h 0. As sin h 0 is 0, so this will be give root 2 sin h t. Therefore the arc length function s of t of the curve alpha of t is root 2 sin h t. So this is what we have to show. So this is about this part. And further we have to find the unit speed reparameterization of alpha. Now the reparameterization of the curve alpha, which is a regular curve, using the arc length function will obviously having unit speed reparameterization. Just using the arc length function we will write the reparameterized of beta. So we can write it as s is equal to root 2 sin ht. So in order to apply the procedure for regular curve, we have to write this equation for t. So we can write t is equal to s by root 2, sin t is equal to sin ht is equal to s by root 2. Therefore t is equal to sin h inverse s by root 2. Now, so we have to replace t with the function of s in case of alpha of t. We have alpha of t as cos ht, sin ht and t. Just replacing t with the function of s. Replacing t with t of s, that is given by sin h inverse of s by root 2. Therefore we get alpha of t will be t of s. So this will be, we can write it as function of s, beta of s. This is equal to cos h of sin h inverse s by root 2, and second coordinate is sin h of sin h inverse s by root 2, and third coordinate will be, so third coordinate is t. T is nothing but sin h inverse s by root 2. Therefore the reparameterization of alpha, which is a regular curve, and is obtained by arc length function s of t is a unit speed reparameterization, because the procedure we have followed to show the reparameterization of regular curve is a unit speed. We have followed the same procedure, therefore it will be a unit speed reparameterization, and is given by beta of s is equal to cos h of sin h inverse s by root 2. Second coordinate will be sin h of sin h inverse s by root 2, and third coordinate is sin h inverse of s by root 2. So we can verify whether the beta of s has unit speed or not. What we have to do? We have to find beta dash of s, and we have to find the norm of beta dash of s, and we have to check whether it is equal to 1 or not. So as we are following the procedure for regular curve, the reparameterization to be unit speed reparameterization, therefore no need to check about whether beta is having unit speed. If you want to check, please check with the equations beta dash and norm of beta dash is equal to 1. So this is about finding the unit speed reparameterization of a regular curve using the arc length function. It's about examples on velocity, speed, arc length function and unit speed reparameterization of the curves. We will see with different concept in next upcoming videos. Till then, keep watching. Thank you.